Hello and welcome. So in this video we'll see how to do a linear programming problem using simplex method. Okay, for simplex methods, what we normally or in general will be given a maximization problem together with less than or equal to constraints. Okay, so when we are given such a problem as shown here, we start by converting that into its canonical form. Okay, so what we need to do is we have to convert this inequality into equalities. So for that we can write the first constraint equation as x1 plus x2 plus we add a slack variable s1 so that the less than or equal to constraint becomes equal to 12. Okay, similarly for the second one we have 2x1 plus x2 and we add a second slack variable s2 so that the inequality turns to equality, and correspondingly we make change in the objective function. Okay, so we have maximize z equal to 40x1 plus 30x2 plus 0s1 plus 0s2. Okay, so this will be our new objective function, and we'll be building our first simplex table or initial simplex table using this data. Okay, so we need the following columns for the simplex table. So we need a column for the basic variable and then the corresponding coefficient, and then we need the coefficients of all the variables. So that will be for x1, x2, s1, s2, and then we need a column for the solution. Okay, and then we need a column, or not column actually section with cj, and in this particular problem we have the basic variable as s1 and s2. Okay, so what you have to keep in mind is for the basic variable, the coefficient of the basic variable in the constraint equations will be 1 in one of the equation and 0 in others. Okay, so here you can see s1 does not come here, so that means the coefficient is 0. Similarly for s2 we have coefficient 1 in the second equation, and for in the first equation we have coefficient as 0. Okay, so that's the definition for a basic variable. So we have s1 and s2, and this cb is the coefficient value from the objective function here. Okay, so for s1 it is 0 and for s2 also it's 0, so we write 0 and 0 over here, and these are the coefficients corresponding to the constraint equations. So when we look at the first equation, we see for x1 it's 1, x2 again 1, s1 1 and s2 0. So we write those values here, x1, x2, s1, and for s2 0. And considering the second equation, we have 2, 1, 0 and 1. Okay, so for x1 it's 2, x2 it's 1, and for s1 it's 0, and for s2 it's 1. Okay, and the solution corresponds to the right hand side of the two equations, so we have 12 and 16. Okay, and then the cj value, that will be the coefficients from the objective function. So we have 40, 30, 0 and 0. So corresponding to x1 we have 40, then x2 30, then for s1 and s2 it's 0. Okay, now we have everything we need, so we can start. So what we do is first we calculate a zj value. Okay, a quantity known as zj, and zj is calculated in this manner. We for each of these x1, x2, etc., what we do is we multiply the cb column with the corresponding coefficient. Okay, so here we have 0 into 1 plus 0 into 2, that will be 0, and here for the x2 we have 0 into 1 plus 0 into 1 again, that will be 0, and since this is 0 over here, everything will be 0 initially. And after calculating zj, we calculate cj minus zj. Okay, so zj minus zj, and so that will be just here in this case cj is 40 minus 0, we have 40, then 30 minus 0, 30, 0 minus 0 and 0. Okay, so these are our cj minus zj values. And for a maximization problem, we select the maximum positive value. Okay, so here you can see the maximum positive value is 40. So what we do is we select this row corresponding to x1 as the pivot row. Okay, so it's known as the pivot row, and the pivot row, like, it corresponds to the x1. So that means in the next iteration x1 will enter into the basic variable column, and we need to find out which among s1 and s2 leaves the column. Okay, so for that we need to calculate a ratio. So for calculating the ratio, we always divide the solution by the pivot column. Okay, so in this case the solution, the value is 12 divided by the pivot column was corresponding to x1, so 12 by 1, so that will be 12. And for the second one it will be 16 by 2, so that will be 8, and we select the minimum of the ratio. Okay, so that will be 8. And then so the pivot row is corresponding to x1, pivot column corresponds to s2, so that means, so I just write it pivot column. Okay, so the pivot column element, that's s2, leaves the basic variable and x1 should enter here. Okay, so that's why we are selecting this pivot row and pivot column. And when x1 is entering, in order for x1 to be a basic variable, what we need is we need one of the coefficient to be 1 and 0 for all other coefficients. Okay, so what we will do is we select this particular element here. Okay, 2, and why we select 2 is because 2 corresponds to the intersection of the pivot row and pivot column. Okay, and we make that element as 1, and we make this other element as 0. Okay, and we do that by using the basic matrix elementary operations. Okay, so in order to make this 1, we just can divide the row 2 by 2. Okay, so the row 2 changes to row 2 by 2, and I'll just write it below. Okay, so x1 will be entering, so I write x1 here, s1 stays as it is, and we had to divide the row 2 by 2, so this becomes 1. We have 1 by 2 here, then we have 0 over here and 1 by 2 here, and for the solution 16 by 2, so we have 8 over here. Okay, and then what we need to do is we have to make this element as 0. Okay, so for that we have to do this particular row operation, the r1 changing to r1 minus r2. Okay, since we have 1 here and 1 here, we just need to subtract the rows. Okay, so here the value becomes 0, and here it will be 1 minus, so this 1 minus 1 by 2, so that we get half again, and here it will be 1 minus 0, so you have 1, and then here 0 minus half, so that will be negative half. Okay, and then here it becomes 12 minus 8, that will be 4. Okay, so we get the next table, and now the CB values corresponding to S1, the value is 0, and for X1 we can see that the coefficient is 40. Okay, so we have to write the value 40 in this column corresponding to X1. And now again we have to calculate the ZJ value. Okay, so here now it will be 0 into 0 plus 40 into 1, so that will be 40, and here it will be 0 into half plus 40 into half, so that becomes 20. Here 0 plus 0, 0, and here will be 0 into minus half plus 40 into half, so that will be 20. Okay, and now Zj minus Zj, Cj value remains the same throughout the iterations. Okay, so if you want you can write it again, or you can just use this value. So here we have again 40 minus 40, that will be 0, and then 30 minus 20, so 10, 0 minus 0, 0, and 0 minus 20 minus 20. Okay, And now what we need to do is we need to calculate the ratio again, or before that we need to select the pivot column, sorry, pivot row, no, pivot column, right? I think in the previous iteration I mixed it up. So this is the column, right? So this is the pivot column and this is the pivot row. Okay, anyway, let's continue. So here we look for the maximum positive value, so that is 10. So this will be our pivot column, and that means x2. So this pivot column corresponds to x2, right? So x2 will be entering here, and to identify which is leaving, we have to calculate, or we have to calculate the minimum ratio. Okay, so here this is the pivot column. So what we do is 4 divided by half, so the ratio becomes 8, and 8 divided by half, so the ratio is 16. Okay, so the minimum of that is 8. So S1 will leave the basic variable, and x2 will enter the basic variable. Okay, so correspondingly we have the pivot element as this. Okay, so corresponding to the pivot column and the pivot row. So what we need to do is we need to change that to 1. So for that I have to multiply r1 with 2. Okay, so I'll draw that. So now here will be S1 will be leaving and x2 will be entering, and x1 stays the same, and correspondingly for x2 the coefficient was 30 and for x1 it is 40. And then for row 1 we have to multiply with 2 throughout. Okay, so this row should be multiplied with 2 throughout. So 0 times 2, again that's 0, half times 2, so we have 1 here, then 1 times 2, we have 2 here, and then minus 1. Okay, and here it becomes 4 times 2, that's 8. Okay, and for the row 2 we need this to become 0, right? Okay, so for in order to make that as 0, what we need to do, we have to multiply, or rather divide this r1 by 2 and then add with r2. Okay, so that is r2 becoming r2 minus r1 by 2. Okay, and please try to always stick to this way instead of writing, like you can also do as 2r2 minus r1, but let's just stick with this way. Okay, and so that if I do here, it will be 1 minus 0 into half, so that will be 1. Here that becomes 0, and now here it becomes 0 minus 2, so we have a negative 1 here, and then this becomes half minus 2 1, right, and this becomes 4. Okay, so this is our new table, and again we need to go for the ZJ calculation. So here we have 40, here we have 30, here we have 60 minus 40, that will be 20. Here we have minus 30 plus 40, so that's 10 over here. And now we can calculate Cj minus Zj. So that will be 40 minus 40 here, 30 minus 30, and then it will be 0 minus 20, so that's negative 20, 0 minus 10, minus 10. Okay, so here you can see that all the Cj minus Zj values are less than or equal to 0. Okay, so once we get Cj minus Zj all less than or equal to 0, that means we have reached the optimal condition. Okay, and the solution will be for x1 we have the solution equal to 4, and for x2 we have the solution equal to 8. Okay, so here we have x1 equal to 4, x2 equal to 8, and correspondingly the objective function was 40 times x1 plus 30 times x2. Okay, so 40 times x1 plus 30 times x2, and that will be 160 plus 240, so that will be 400. Okay, so this is the value for optimal value for the objective function, and these are our solution for the x variables x1 and x2. Okay, so this is how you do a simplex method. And one additional thing I have to mention is that suppose when we are having right hand sides equal to 0 or something, okay, or like if you have 0, then we get the ratios as 0 here. Okay, so what we need to, or what you have to keep in mind is, if the ratio is coming to be negative, you do not select that. Okay, you just ignore it, or even though the negative value is smaller, if the ratio is negative, you always ignore it. Okay, so I'll just write that. So if we have a negative ratio, just ignore it. And if you are getting a 0 ratio, okay, and that 0 is obtained by dividing a negative number, okay, 0 obtained by dividing with negative, then you just ignore that also. Okay, but if you are getting the 0 that is divided by or you obtain 0 by division by a positive number in the minimum ratio column, then that can be selected, okay, as the minimum ratio. Okay, so whenever there is negative happening, or like for example here you have a negative number, and if suppose this was the pivot column, then you will have a negative number over here, so that will not be considered. Okay, and suppose here you had 0, and then you're dividing that 0 by a negative number, your ratio is 0, but still you will not consider it because you have divided by a negative number. But here suppose instead of 8 you had 0, and then you are dividing 0 divided by 1 by 2, again you have the minimum ratio as 0, and this time you will select it. Okay, so just keep that in mind when you are doing the problems. Okay, so I guess we are done with the simplex problem. So in the next video we'll try the big M method. Okay, thank you.